Hello everyone, welcome to my video. Today I'm gonna guide you through on charging system on H-bridge inverters. I know many people have been asking how does charging system on H-bridge works, considering the kind of transformer you're using, which is half a voltage of the inverter system. It just shows if your inverter is 12 volts, your transformer will be around 6 to 7.5 volts. And if it is 24, your transformer will be around 14 to 15 volt. So people begin to get confused. How does this charging system works? So now I'm going to show you the techniques and how the charging systems work. Now you can check carefully the H-bridge. Let's check. You can see I just type it on Google H-bridge. I just want to take you basically so that you will understand it very clearly. Let me just check here. Let's check here. Just follow me gradually, you're going to understand. Now, this is a typical view of how an H-bridge works. You can see the top V-bar, that is the battery positive, and the arrow below, which is the negative. Now, when your battery is connected, the capacitors connected in parallel to this battery is what makes your inverter spark from initial. Are we together? It's what makes your inverter sparks. Now, the Q1 and the Q2, the Q3 and the Q4 are all MOSFETs. That is what makes it H-bridge. So when Q3 is on and Q2 is on, it allows current flow from V battery, that is battery positive, through Q3 and follows through the transformer and to Q2 and follows through Q2 to ground. Then it ignites lights. That is how your H-bridge inverter works. So why we choose half of the voltage of your transformer is because the Q3 here from the top and the Q1 switches on high side. They switch the MOSFET full, while the Q2 switches the MOSFET halfway. I don't know if you understand. Okay. The Q2 does not switch your MOSFET more than 6 volt. It does not switch your MOSFET more than 6 volt. And your MOSFET needs more than up to 10 volt and above to switch on or to open completely. So the Q2 and the Q4 are the reason why we choose our transformers half voltage. You need to put that in mind. Not the Q1 and the Q3. It is the Q2 and the Q4, which are the low one, L1 and L2. They are the reasons to why you choose transformer half a voltage. So that when the top side opens fully, the downside opens half and it makes it a full cycle to generate the expected voltage. Now, the charging, many people ask, how does the charging system of the H-bridge works? How does the charging system of the H-bridge works? Now, one thing you need to know is the H-bridge charging goes most of charging boost charging system. When I say boost charging system, let me show you a very typical example of a boost converter. Please follow me carefully. Let me show you. Boost converter. Okay, sorry. Let me check the circuit. I'm using the Chrome so that you can easily make research and bring up your questions by yourself. So let me check a very simple boost converter circuit. And I'm using the Chrome so that you can easily access it. You can easily have access to it. So that is why I'm using Chrome. So you can see on this boost converter, this is the source voltage. Are we together? This is the source voltage. Now, if you check, the source voltage is going through a transistor, an inductor. Now, this inductor in your inverter is the transformer secondary winding. Is your transformer secondary winding. So, if you check carefully, the diode after the MOSFET, if you check the diode after the MOSFET, it serves, and sorry, let me open another tab so that you will easily understand this. sorry, I am using I want to use it this way so that you can easily now check carefully on this picture I was using earlier. Now, the Q2 here is on the low side. The Q2 and the Q4 are on the low side. So, while your H bridge is charging, the Q1 and the Q3 turns off completely. Now, the Q2 and the Q4 continues to switch. Are we together? The H1 and the HQ stop switching. The Q2 and the Q3 continue switching at a very high frequency. Now, between the M you are seeing here now is a motor, but it is a transformer that is supposed to be there, which is that of an inverter. So, okay, or let me look for an inverter transformer so that you can easily understand. Let me look for the one that has a transformer between. Yes, this is it. Now, the induction here, as you can see, the M here is your transformer, your secondary winding transformer. Your secondary winding transformer, that is the 7 volt. So the A and the B here below switch consistently on a very high frequency, so that it will work as a boost converter. So when it opens, this MOSFET here at A below, that is Q4, the MOSFET at Q4, when it switch on, it allows this inductor to charge. Are you getting me? It allows this inductor to charge. That is charging from VDD. Sorry for the call. Charging from VDD. From the VDD, it will follow through Q1 and sorry for the call. It will follow through Q1 to Q4. Are we together? Now, after then it charges the transformer, the inductor that is on the secondary winding. Sorry, let me put my phone on flight mode. It charges. So after charging, once it closes, it will discharge through Q1, and equally Q3 will discharge through Q2. So the Q1 and Q2 that is short will now become a diode, whereas blocking every current generated by this L1 L2 switching. So it will block the current from reversing, so the current will keep going to your battery, whereas the top H1, the Q1 and Q2 are consistently off, so there will be no switching. Now, you can see that it is the same process happening in your boost converter here. The inductor here serves as a transformer, then the MOSFET here serves as one of the switching MOSFET, that is the L1 or L2. So if you check, there is a diode ahead. So the diode now is to block any current that has been boosted from reversing. Then the capacitor is the capacitor that is in your inverter, in your H bridge, those big capacitors. So you could check and understand that it is the same process that your H bridge uses in charging. That is why they use half voltage of your inverter. Now, for the last video I posted on EGS002 inverter system, and I have not implemented the charging system of EGS002. So I'm about to show you how to implement the charging system on EGS002. So let's take a look at the circuit diagram again of EGS002. EGS002. I told you why I'm using my browser, so that you can easily navigate from your own end. Sorry. I told you I'm using my browser so that you can easily navigate from your own end and equally make research, and if there is any question, you can drop it on the comment below. Alright, sorry, I turned off my here we are. So this is the EGS002. Let me show you a very simple circuit of the EGS. Sorry, let me check images. Okay. Aha. Sorry, my internet connection is taking longer than expected. Now I could still recall this was the circuit diagram I used for the video. So for many of you who have not gone through the video, you can check on the description below. The video link is there. Now if you check this circuit diagram gently, you can see it does not have charging system. It does not have charging system. So in order for us to be able to implement a charging system for this EGS002, this pure sine wave inverter, is if we can get an oscillator that can switch between L1 here and L2, that is the two MOSFET that are below. Now this is what we are going to do on this particular circuit diagram. As I've said, for many of you that have not seen the video, you can check the description below and watch it before going through this one. Now what we need to do for this whole system of EGS002 is for us to be for it to enable us to make a charging system. One thing you need to, these are the things you need to put into consideration. Number one, the switching time from inverter to mains and from mains back to inverter. And number two, this IC, this EGS002 needs to be standby on when there is NEPA supply. That is, when your inverter is on and is switching back to NEPA, it's supposed to remain on. Now there are two ways of implementing this thing. There are two ways. I will show you the other way. But for now, the charging system has to go by these two MOSFET that are below. That is the one that are L1, L2. They are the MOSFET that are to keep switching when your inverter, when there is light. So what we are going to do is we are going to get another separate oscillator. Another separate oscillator that will be switching between these inverters below. So it means we are going to get, let's go back to our SG3524 quickly. SG3524. Alright, good. I could remember we have this circuit. This one here, I could remember this was the circuit I added. So you can still design this circuit. Yes, you can still design this circuit and make use of it for your charging system. Now, instead of connecting this MOSFET here for the transformer, this the oscillator output, that is pin 14 and pin 11. We are going to connect it to L1, L2 of the EGS. Sorry, let me switch between my tabs. Now, the connection of the SG3524 will be connected to Q3 and Q4 on this diagram, so that it will switch alternatively. So that shows your L1, L2 will be using two oscillators. Now, in order to be able to implement this, you have to design this circuit separately, and you are to use the same transformer you are using for your inverter. Sorry for the call. Sorry for the interruption. You are to use the same transformer you are using for the inverter for charging. Now you are going to design this same system. Now let me show you a typical system of the charging. Edge bridge charging technology. So let's check. There is a circuit available online. Quickly, let me show you how it works. Sorry for the calls. I forgot to put my phone on forwarded calls. Sorry about that. HV charging technology. Okay, sorry, it's like I used the wrong keyword. So it should be inverter charging using EGS002. Oh, here we are. You can click on this one. This circuit here. So let me visit the page. So the inverter charging circuit, as you can see here above, is you can just scroll since what I'm going to show you is something different. So please follow me carefully. I want to enlarge. I want to open the image large. Sorry. Just follow me carefully. Let me open the image in a new tab. Oops, it's not opening. Sorry. So I would have loved you to see this image clearly. Sorry. Due to ads and some. Oh my God, the image is not opening. Now, ouch. I wish I could zoom this more than this. Now, you can equally. I'll drop the link on this particular material below, so you can access it from your own end, but it works perfectly. So you just need to make that circuit, that oscillation circuit, to generate a pulse width signal, and after then, that the circuit. Okay, sorry, it's like I've seen another one. The circuit is the same. It's good. I think this one is more clearer. I think this image is more clearer. Let me see if I could access this. Oops, I'm still having the same thing. Alright, let me navigate it from Google here. Now, if you check carefully in the switching, you can see D1, D2, Q1, Q2. Now, the D1, D2 here is the MOSFET of your H bridge. That is the H1, H2. Now, why they use diodes here is because the MOSFET will be closed. So once it is closed, it automatically becomes a diode. So I wish this image opens completely so I can show you clearly. But notwithstanding, let's go back to this circuit. What they did there is the same thing. The only thing is the feedback. That is pin 1. The only difference with that other circuit I just navigated to this one is the feedback. And as I've said, the pin 14 and pin 11 will be connected to. It will be connected to the L1 and L2 of your H bridge of the EGS. Then these are C1, that is at pin 7. You are going to replace it with a 103. 103, that is 10 nanofarad capacitor. That is 103. Then the resistor will be replaced with 100K. That is all for this circuit. Then the feedback now, you are going to connect a variable resistor. The middle pin of the variable resistor will come to pin 1 of this SG3524. Then last pin will go to ground. Are we together? Then you get a 33k resistor that will come from the battery positive pin. That is from the H bridge. The battery positive pin will then come to pin 1. So now this explanation I've made is for 12 volt system. So if you want that for 24 volt and 48 volt system, you can equally drop your request on the comment section below. I'll make that ready. Thank you for watching this video. See you on the next video.